Okay, this is Gauss Lemma. The statement of the lemma is, if the primitive polynomial fx, what does it mean by primitive polynomial? The definition of primitive polynomial states that the GCD, greatest common divisor of every coefficient of each term, means GCD of all the terms of the polynomial fx is always 1. That is primitive polynomial. So our theorem is, if the primitive polynomial fx can be factored as the product of two polynomials having rational coefficients, means this primitive polynomial has coefficients in rationals, then it can be factored as the product of two polynomials. Then again, this can be factored as product of two polynomials having integer coefficients, means we can convert two product of two polynomials which they have coefficients in integers. Okay, so the condition is, if product is having rational coefficient, then we can show the product is having integer coefficients. So let me start this theorem. Suppose that fx is the polynomial which can be factorized as alpha x into beta x, where alpha x and beta x are two polynomials, where alpha x and beta x are two polynomials with rational coefficients. Okay, I will take together one example here. Suppose that this fx is a polynomial of like 1 by 2 plus 3 by 4x plus 4 by 8 x square plus, and this way so on up to suppose that 2 by 8, 2 by 5 x to the power 3, this type of polynomial. We are looking that coefficients are in rationals, yeah, this type. So when the coefficients are in rationals, you can again consider that you can take common from numerator and from denominator, means from each coefficient you can take some common elements, or you can multiply both sides by you can take LCM of 2, 4, 8 and 5. When you take the LCM of 2, 4, 8 and 5, this is 40, so you can multiply this all number by 40 and you can clear the denominator. Sometimes it may be in the form of a by b, means numerator has something and denominator has something, and you can clear the denominators by operating this way. Do you understand this? Like when you multiply with 40, 2 20s are 40 and 4 will divide to 40 is 10. In this way all the denominators can be cleared by taking some element in common from here somehow. So on that basis you can say that by clearing of denominators and taking out commons from numerator, taking out common factor, we can write this polynomial again fx can be write in form of some a upon b ux, the first polynomial will change, and vx, the second polynomial also will change. The polynomial will be something different. Like here I have taken only one example of one polynomial, your alpha x, and same way here something is beta x, and from here also you can take some common, from here you can take some common, and after taking common the polynomial will change its shape, its face will be changed, polynomial will be changed, beta will be changed into vx, alpha x will be changed into ux, while taking common and eliminating the denominators from each of the polynomials. So here after eliminating denominators and taking common factors, a and b is as the common, and the polynomials are changed here. You can see here alpha x is changed to ux and beta x is changed to vx. And where a and b, these coefficients are integers and these ux and vx have integer coefficients because all the rationals are removed, have integer coefficients, and together they are primitive too. They are primitive too because we have taken common. Since you have taken common, so GCD will not be more than 1. GCD of ux will be 1, GCD of vx. It means GCD of coefficients of vx will be 1, GCD of coefficients of ux will be 1, because the common factors are taken outside. Okay, like here in this example, when you take all the common factors outside, so always the GCD will be 1. Like if you multiply by 40, this will be your 20, and plus like this is you can see 4 10 and this is 30 x plus 8 5 20 x square, plus like here 5 is 16 x cube, and you take when the common outside, this is 40 by 40, it is 40 by 40 now the common, and when you take common from here, what will be the common at least it will be 2. If you take 2 the common outside and this is gone inside, you can write here like 10 plus 15x plus 10x square plus 8 x cube, and 2 will be common, 2 upon 40. This is a, this is b, and the GCD of these elements will be equal to 1. Okay, GCD of these elements means the polynomial will reduce to a primitive polynomial. Okay, I have shown some example here. So the coefficients are integers and ux and vx are primitive polynomials. This implies, sent to be to the left side, we can write bfx is equal to a ux to vx. So if you watch the left side, fx is a primitive polynomial. In left hand side, fx is primitive, so the total value b into fx has content b. What does it mean by content? Content means when b is multiplying to all the coefficients of fx, then GCD of multiplied polynomial will be equal to b. And yesterday's definition we had seen in last period definitions. What is the content of polynomial? The content, you can see here that content of polynomial is, suppose that this is a polynomial, and if you take GCD of all the coefficients, whatever the number is, that number is the content. So I will show you one more example to make you understood. Suppose that there is a primitive polynomial fx is equal to like 1 plus 2x plus 3x square plus 4 x to the power cube. Suppose that, and if you multiply this polynomial by any number, suppose that you are multiplying this polynomial by 3, so the new polynomial will be 3 6x plus 9x square. And so what will be GCD of these coefficients like 3 6 9 and 12? What will be GCD? GCD will be 3. It is exactly this number. Okay, GCD will be 3. So on that basis we said our result that in LHS, since fx is primitive, so b into fx has content b, and similarly since right hand side, since in right hand side ux and vx both product ux comma bx both are primitive, and therefore the product ux into vx is also primitive. So the whole product AUX into BX is has content. What is the content of this? Its content is A. So we concluded that the content of left side is B and content of right side is A. Okay, so the content of left side of primitive polynomial and content of right side of primitive polynomial, they should be equal. This implies B should be equal to A. This implies B upon A should be equal to 1. If you put this value in our equation number 1, substituting this result in equation 1, we have fx is equal to ux into vx. So we have proved what is ux and vx. Ux and vx are the polynomials with coefficient as integers. Therefore, fx is factorized as product of two polynomials ux and vx with integer coefficients. This way we have proved our theorem. So have you written this, or you want to take any snap of this?